Hello my precious friends, I really hope that you are doing great. Welcome to today's class. It's our 11th lesson on a given form 3 mathematics topic called sequences and series. So we are looking at our 6th example on geometric progression, which is a past cases equation tested in 209, paper 2, question number 23. It reads that the first term of an arithmetic progression is 2. The sum of the first 8 terms of the AP is 156. So in part A, Roman 1 of the question, we are required to find the common difference of this particular arithmetic progression. Now, we are told that the first term of this particular AP, we know that the first term of either an AP or a GP is always denoted by small a, which we are given to be positive 2. Then the sum of the first 8 terms of the same AP is 156. Therefore, S8 should be equivalent to 156. Now, we know that the sum of terms for any given AP is given by the formula n over 2, then into bracket 2a, then of course plus n minus 1 multiplied by d. So, for me to find S8, I'm going to substitute the values as the number of terms will be 8 over 2, then of course into bracket 2 multiplied by the first term I'm given as positive 2, then of course plus 8 minus 1, then multiplied by the common difference d. So if I simplify, I'll end up with 4 into bracket 2 by 2, I'll get 4, then plus 8 minus 1, I'll get 7, then of course multiplied by d. But because I'm given S8 is equivalent to 156, and also S8 is equals to 4 into 4 plus 7d, it simply follows that 4 into bracket 4, then of course plus 7d must be equivalent to 156, because they are both equivalent to the sum of the first 8 terms of this particular arithmetic progression. Now, to simplify this, I'll divide through by 4. So I'll divide through by 4. I also divide through by 4 so that 4 and 4 can cancel out. So I'm going to remain with 4, then plus 7d being equivalent to 156 divided by 4. I'm going to get a positive 39. So that means that 7d will be equivalent to 39 minus 4. I'm going to get positive 35. Then I divide through by 7. I also divide through by 7. So it means that the value of d, which is the common difference, will be equal to 35 divided by 7, of course, which is going to give me a positive 5. So we've answered, that is part A, Roman 1 of the question, because they wanted us to find the common difference of this particular AP. Then we are going to move to part A, Roman 2 of the question. Now, in Roman 2, we are being told that given that the sum of the first n terms of the AP is 416, find the value of n. We are being told that Sn is equal to 416. Then we know that Sn is given by the formula n over 2, then of course into bracket 2a, then of course plus n minus 1 multiplied by d, so that this one is equivalent to 416. So if I substitute the values that I'm given in this particular case, of course I already have I don't have n, so I'll have n over 2, then into bracket 2 multiplied by a. I was given the first term to be 2, because remember we are still dealing with the same AP. So the first term was 2, then plus n is the number of terms which is not known, minus 1 multiplied by d. The common difference, I've just found it to be positive 5. Then I close the bracket. So the whole of this should give me 416. So this will be n over 2. Then into bracket 2 by 2, I'll get positive 4. Then plus 5 by n, I'll get 5n, minus 5 times 1, I'll get negative 5. Then this one should give me 416. So to simplify this, I'll multiply through by 2 just to eliminate the fraction to make my working easier, so that 2 and 2 can cancel out. So I'm going to remain with n into bracket. So I can also simplify the numbers within the bracket. I'll start with 5n. So I'll have 5n. 4 minus 5, I'll get -1. Then close the bracket, is equals to 416. If you multiply it by 2, you're going to get 832. So if I open brackets on the left, I'm going to have 5n squared, then minus 1n being equal to 832. So this will give me 5n squared minus 1n minus 832, which is equals to 0. Of course, this is a quadratic equation in the form ax squared, then plus bx plus c is equals to 0, where the value of a will be 5, the value of b will be -1, and of course the value of c will give us negative 832. Remember, we are required to find the value of n. Therefore, I'll use my quadratic formula to solve for the value of n, so that we are going to get the following. So this will give us the following. So the quadratic formula requires that the value of n be given by -b plus or minus square root of b squared, then minus 4ac, then the whole thing divided by 2a. Remember, this formula is found at the back of your math table, so you don't need to cram it. So this will give us -b will just be -1, then plus or minus square root of b squared. Our b is -1 squared, then minus 4, then of course multiplied by a. Our a is +5, then c is -832, so 832. Then the whole thing is divided by 2 multiplied by a. Our value of a is 5. So n will be equivalent to -1 by -1. That is negative by negative, you'll get +1, plus or minus the root of -1 squared will just give you a +1. -4 times 5 times -832. Of course, negative will give you a positive. So you'll get a positive 640. That is the multiplication of 4 by 5 by 832. Then divided by 2 by 5, you'll get +10. So this will give us 1 plus or minus the root of 1 plus 640. You'll get 16641 divided by 10, which of course will give you 1 plus or minus the square root of 16641. If you use your calculator, you'll get 129. Then the whole thing is divided by 10. Now, let me proceed with my working from this particular end here. So, we are going to end up with the following. So, our n, so this one means that either the value of n is given by 1 plus 129 divided by 10, which will give us 1 plus 129, I'll get 130 divided by 10. So, of course, this one will give me +13. Or n can as well be given by 1 minus 129 divided by 10, which of course will give me -128 divided by 10, which will just be equivalent to -12, then of course 0.8. But what was n representing? Remember, n is representing the number of terms. Then we said that the number of terms must be a positive integer. So we are going to say that n cannot be equivalent to -12.8. The reason is because or since this one is because or since the number of terms that is n, the number of terms n must be a positive integer. It must be a positive integer. It must be a positive integer. or what we call the natural numbers, or a positive whole number. Into bracket, we can talk of it must be a positive whole number, a positive whole number. So that is what we mean by a positive integer. Therefore, we are going to conclude and say the number of terms n will be 13. So we'll have 13 terms. So these are the number of terms of this particular AP. Then let's proceed to part B of our question. So in part B, let me erase this particular area here so that we can use it to continue our working. So in part B of the question, we are being told that in part B, we are being told that the third, the fifth, and the eighth terms of an AP, they form the first three terms of a GP. If the common difference of the AP is 3, find Roman 1, the first term of this particular geometric progression. So what we are going to do in this particular case is to find this particular, the third, the fifth, and the eighth terms of this particular another AP. So the word another AP in this particular case simply means that we are going to use a different common difference and a different that is first term, unlike the first term for the first AP, which was actually 2. So this is part B, Roman 1 of the question. So we are told that the third, the fifth, and the eighth term of another AP. So our other AP is going to behave in the following way. Let me actually erase this. So our other AP will have the following terms. We know that the nth term of any given AP is given by A, then of course plus n minus 1 multiplied by D. Therefore, we are told that the common difference of this new AP, the common difference is 3. We are being told that D, we use D as 3 as the common difference of this particular new AP. Therefore, the third term of the AP will be given by the following. So the third term of the new AP, the second AP, the third term will be given by, so we'll have A, which is representing the first term, then of course plus, n will be 3, then minus 1 multiplied by, we are given the common difference to be 3. So this will give us A, then of course plus, 3 minus 1 will get 2, 2 multiplied by 3, we are going to get a positive 6. Then the fifth term, so the fifth term of this particular AP will be given by, so we'll have A, then of course plus, our fifth term will be given by 5 minus 1 multiplied by D. Of course our D is 3, so this is going to give us A, then of course plus, 5 minus 1 we get 4, 4 by 3, we're going to get positive 12. Then the eighth term, so our eighth term will be given by the following. Eighth term of the AP, that is the second AP, will be given by A plus 8 minus 1 multiplied by D. Our common difference, we are told to use 3. So this one will give us A, then of course plus 8 minus 1, we get 7. 7 multiplied by 3, we are going to get 21. So this will give us A plus 21. Therefore, these are the third, the fifth, and the eighth terms of the second AP. Then you are told that the third, the fifth, and the eighth terms of another AP, they form the first 3 terms of a geometric progression. So it means that this particular GP, its first term, this will be the first term of the GP being formed. Then the fifth term will be the second term of the GP, which is being formed. Then the eighth term will be the third term of the GP that of course we are forming. Therefore, we are required to find the first term of the GP. So remember, the first term is the first term of the GP. So it means our GP is actually going to have the following terms. So the GP is going to have the following terms. the first term of the GP is A plus 6. The second term of the GP will be A plus 12. Then the third term will be A plus 21. So these are the first three terms of this particular GP which will be formed. But we know for us to find the values of the unknown, that is A, we are going to apply the concept of the common ratio. We know that the common ratio must be given by, we take the term ahead, that is the second term, which is A plus 12. We divide with the previous term, which is A plus 6. It must be equal to the third term, which is the term ahead, A plus 21, divided by the term before, which is the second term, which is A plus 12. So all these should be equivalent to the common ratio. Now, I'm simply going to do what we call cross multiplication. So these will multiply with that. Then, of course, this one should multiply with this. So we are going to end up with the following. That is when we do cross multiplication. We are going to end up with A. So I'm going to have into bracket, I'm having A plus 12 multiplied with A plus 12, which should be equivalent to A plus 6, which should multiply A, then of course plus 21. So if I open this bracket, of course I'm going to expand. So I'll have A into bracket A plus 12, then of course plus 12 into A plus 12, which should be equal to, if I expand the second part, I'll get A into A plus 21, then of course plus 6 into A plus 21. Then I close the bracket. So the first bracket here is going to give me A squared, then plus A times 12, I'll get 12A, then plus the second bracket here, I'm going to get 12 multiplied by, I don't need this bracket here. So this is 12 multiplied by A, I'll get 12A, then plus 12 by 12, I'll get 144. 144 being equal to, the second bracket here will give me A squared, then plus A by 21, I'll get 21A, so 21A. Then of course, I'm going to add 6 by A, I'll get 6A. Then 6 multiplied by 21, I'm going to get positive 126. So I'll get 126. So of course, there are terms which are going to cancel. That is A squared and A squared. Because when A squared crosses equal sign, it will become a minus. So we'll remain with, if I add these two, I'll get 12 plus 12, I'll get 24. So I'll have 24A plus 144 being equal to, on the right hand side, I'm having 21A plus 6A, which will give me 21 plus 6. I'm going to get positive 27. So this will give me 27A, then plus 126. So 27A plus 126. Then I'm going to collect the like terms. So I'm going to have 27A minus 24A being equivalent to 144, then minus 126. So we are going to end up with the following. Let me clean this area here so that we can use it to complete our working to find for the unknown values, that is the value of A. So this is going to, we are going to end up with the following. So 144 minus 126, I'm going to get positive 18, being equal to 27A minus 24A, I'll get 3A. So this is 3A. I divide through by 3, divide through by 3. So of course, we'll end up with the value of A being equal to positive 6. So A is positive 6. But the question did not ask us to find A. Remember, A in this particular case is representing the first term. This is the first term. The first term of the AP. This is the first term of the arithmetic progression. But the question wanted us to find the first term of the geometric progression. Therefore, the first term of the GP of the geometric progression will be given by, from the AP, that is from the GP that we had formed, the first term was A plus 6. So it is A plus 6, which is equals to, our A, we have found it to be positive 6. then plus 6. Of course, this will give us 12. Therefore, 12 is the first term of this particular geometric progression. Then we are going to move to Roman 2 of the question. So in Roman 2, so this is B Roman 2. B Roman 2, they want us to find the sum of the first 9 terms of this particular GP. So to find the sum, of course, we have two formulas. So to determine the formula, we must know the common ratio first before we identify the formula to be used. So the common ratio was given by this equation here. So let me use this first part to find my common ratio of the GP. So it was A, then plus 12, then divided by A plus 6. So this will be equivalent to, my value of A was 6. So this is 6 plus 12 divided by 6 plus 6. So that means our, let me clean this area here so that we can complete the working. So that means we are going to end up with the following. So our common ratio will be given by 6 plus 12 will get 18, divided by 6 plus 6 will get 12. So by 4, 2 times, then of course, no, we can try by 6. By 6 2 times, by 6 this will be, by 6 this will be 3 times. So our R, which is the common ratio, is going to be 3/2, which of course is 1.5, which is giving us 1.5 as the common ratio. Now that we have the value of the common ratio, we can determine the formula that we can use to find Sn. Clearly, we can see that 1.5 is far much greater than 1. Therefore, it means that our common ratio is greater than 1, and therefore, the formula for Sn to use when the common ratio is greater than 1, of course, we said the formula was A into R to the power of n minus 1, close the bracket, divided by R minus 1. So the value of R is the one that will tell you the formula to use. So if I substitute the values, it means that S, we are required to find the sum of the first 9 terms of the GP. So S9 will be equivalent to the first term. Of course, we found the first term of the GP to be 12. So this is 12. Then into bracket R, our value of common ratio, we found it to be 1.5. So this is 1.5 to the power of n. Of course, our n is 9 because we are talking of 9 terms. Then minus 1. Then we close the bracket, divided by, let me close the bracket, then divided by 1.5, which is the R, then of course minus 1. Now, when we simplify this is what we are going to end up with. On performing simplification, this is what we are going to end up with. So when I simplify, this is what I'm going to get. So we'll get that S9, the sum of the first 9 terms, will be equivalent to, we'll have 12, then into bracket 1.5 to the power of 9, then minus 1, close the bracket, divided by 1.5 minus 1, of course we are going to get 0.5. So I'm going to separate the working. So I'll have 12 divided by 0.5, then into bracket 1.5 power 9 minus 1. Now when you perform 12 divided by 0.5 is just the same as 12 divided by a half. So when you divide by a half, it means you'll multiply with the reciprocal. So it will be 12 multiplied by 2/1, which is the reciprocal of a half. 12 by 2, you'll get positive 24. Then into 1.5 to the power of 9 minus 1, then close the bracket. Now, when you feed this on your calculator, 24 times, open bracket, 1.5 power 9 minus 1, your calculator is going to give you the following answer. So you'll get 898, then 0.640025. This is what you are going to get on your calculator. But remember, we were told to leave our answer to 4 significant figures. This is the first significant figure, the second, the third, and the fourth. Therefore, to 4 significant figures, our answer will be 898, then 0.6. This is correct to 4 significant figures. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified.